So now what we are doing is we are trying to find a relation between U, V and R. So what we have is, we have a spherical surface. Now we already know the refraction, how refraction happens through a spherical surface and different Cartesian sign convention, right? Now what we are doing here is we are assuming that the object lies in the rarer medium and the image formed is real and the image is formed in the denser medium. So let's start with drawing one spherical surface. So what we are doing is we are taking a convex spherical surface. Okay, so this is a convex spherical surface, and then what we have is we have the principal axis here, and since it's a spherical surface, so what we'll do is we'll try to make it more like a complete object. So writing a figure like this, so we can say that it's a complete object. So what we have is we have the rarer medium. So let's say this is the rarer medium. We'll call this as mu1. This is the denser medium, mu2. Now, this is the pole, P. Let's say an object is placed here, O. Now, remember, the object is in the rarer medium. All right. Now, the ray of light, so which comes from O, let's say it is meeting here. So let's call that point as A. So what we have is OA is the incident ray of light. Now, an object is formed in the rarer medium. So somewhere over here. So let's call this point as I. So AI is the refracted ray. All right. Now what we have is, let's say this point C is the center of curvature. Now from the center of curvature, what we draw is we draw a normal. So we draw a normal. Let's say this is the normal. Now what we have is, so since that is the normal, let's call this point as, let's say, B. Now OAB angle, this will be angle I, the incident angle, and CAI, so this will be the refracted angle R, right? Now what we have is, so from A, what we do is we drop a perpendicular onto the principal axis. So from A, you drop a perpendicular. So this perpendicular plays a very important part. So let's call this point as N. So N is basically 90 degrees. All right. Now what we have is, so we have I, we have R. Now let's call this angle as alpha. Okay. And let's call this angle as beta. And let's call this angle as gamma. So don't get confused, my R and gamma looks almost the same, but remember this is gamma. So ACN angle is gamma. That plays a very important part. Now what we have here is in triangle OAN, so we take tan of angle alpha. So tan of alpha will be nothing but AN divided by NO, right? Then in triangle AIN, what we have is, we'll take tan beta. So tan beta will be AN divided by NI. And in triangle ANC, if you take tan of gamma, we have AN divided by NC. Now, if you look at the figure, P and N are very close to each other. So any distance we have to calculate from the pole, right? So NO is almost equal to PO. So what this happens is, this will become AN divided by PO. And this almost becomes AN divided by PI. And this almost becomes AN divided by PC. Okay, what we have is, once we have got all these things, see, one more important thing is this distance is nothing but u, right? And from P to C, this is nothing but R, and from P to I, this is nothing but V, correct? So what we have is we have U, V, and R. So we have these three, right? Okay, the next important thing is if you consider triangle AOC, that is in triangle AOC. Now, I is the exterior angle of the triangle, correct? Now, by the law of triangles, what we have is exterior angle is equal to sum of the opposite two interior angles. So, we have I is equal to alpha plus gamma. Right. Now, for small angles of alpha, beta, gamma, tan of alpha, tan of beta, tan of gamma is almost equal to alpha, beta, gamma. Right. This is the assumption again what we are doing. So, I is equal to alpha plus gamma. Now, alpha is nothing but an by PO and gamma is nothing but an by PC. So, we substitute that here. So, what we get is I is equal to an divided by PO plus an divided by PC. So this is what we got as I value. So call this as equation number 1. Alright. Then what we have in triangle, see here gamma, R and beta are there. So in ABC, so in triangle, sorry, AIC, we have gamma is equal to beta plus R. So R is equal to gamma minus beta. So this is gamma, what I'm writing. So R is equal to gamma minus beta. Right. Again you substitute. So you will get R is equal to an divided by PC minus an divided by pi. So we have a value for I and call this as equation number 2. So we have a value for R. Now see, we have I and R. You have mu1 and mu2 to be the refractive indices of two materials or medium. Now suppose let's say we have the relative refractive index, that is, let's say mu is equal to mu2 divided by mu1. Then what we have is this is nothing but sine of I divided by sine of R, right? Basically Snell's law, what we are talking about. So since we have Snell's law here, now what we have, so if you cross multiply, so you will get mu1 into sine of I is equal to mu2 into sine of R, right? So mu1 sin I is equal to mu2 sin R. Now we know the value of sin I and sin R. Now see, one more important thing, for small angles of I and R, obviously sin I is almost equal to I. Again, remember this is one of the assumptions. So we have mu1 into I is equal to mu2 into R. What is I and R value? We already have from equation 1 and 2. Substitute. So you have mu1 into an by PO plus an divided by PC is equal to mu2 into an divided by PC minus an divided by pi. So mu1 I is equal to mu2 into R. Now everywhere an, if you take common, you can cancel all the an's, right? So what you have is mu1 into 1 by PO plus 1 by PC is equal to mu2 into 1 by PC minus 1 by pi. So this is what we got from all the equations what we solved above. Now applying the sign conventions, now PO is nothing but minus U, right? And PI is plus V and PC is plus R, correct? Because the radius of curvature, it is along the direction of the light. So if you substitute, so what you get is mu1 into 1 by minus u plus, now PC is plus R, so 1 by R is equal to mu2 into 1 by R minus 1 by, see, Pi is plus V, right? So this will be nothing but minus 1 by V, right? Now, here we have 1 by R, here we have 1 by R. So if you actually take it to the other side, and if you simplify, so you will get minus mu1 by U plus mu2 by V is equal to mu2 minus mu1 divided by R. Alright, so this is what we call as the relation between U, V and R for any type of a lens. Alright, so this gives us the relation between the two refractive indices of the media, the object distance, the image distance, and the radius of curvature. So what we did is, for an object which is placed in the rarer medium and the image is formed in the denser medium, and the image is a real image.